Thank you, dear Antonio, for giving me the opportunity of speaking. I am Guillaume Delaplace. I will cut my camera now, just to let you see the screen. Okay, so for this first presentations, in the webinar conference, I have decided to present what we are, and I will attempt to illustrate what our main type of research activities around fouling and cleaning. In future event, I will present result we have obtained illustrating influence of calcium on platelet exchanger fouling for various whey protein solutions it treated in platelet exchanger. So what we have, PIHM group is a team of UMET research unit regrouping some INRAE staff which investigates food processing in reactor and bioadhesions of soils in food process equipments. INRAE, whole name is INRAE, is France National Research Institute for Agriculture, Food and Environment. It is Europe's top research institute in this field. UMET is a joint unit research based at Lille in the north of France, dealing with materials for different applications. One of its applications concerns foods. UMET is about 200 people, 80 of them are permanent researchers, 80 of them are PhD students or postdoctoral positions. Patrick Oisel is the director of this unit, and I am deputy director. So UMET is divided in 6 teams, and PIHM groups is one team of UMET located in its old building close to Lille University campus. So now PIHM's scientific project is to understand the mechanism governing food process in reactor and contamination of surface in agro-food industry with the aim of improving cleaning of food processing line. Issues are food safety, quality, sustainability of food processing, which meets INRAE challenge. PIHM staff is composed about 40 people, and half of them are permanent agents. We have a technical hall of about 800 square meters containing platform for the thermal treatments of food products. This hall contains batch and continuous equipment at pilot plant scale, and also automated cleaning in place stations. We have also analytical facilities, microscopy and spectroscopy device, allowing characterization from macroscopic to nanoscopic scale. We collaborate with different partners, academics or industrial. We use various contractual frames for collaborative research projects with industrial. Academic collaboration are with other research laboratories like us, located in France or in foreign country. In this field, we participate in 2 international laboratories, one of them with Suzhou in China, and another starting one with University of Viçosa, Brazil. Industrial can be food processor, equipment manufacturer, cleaning solution providers. Typical project carry out are investigations in order to quantify momentum, heat mass transfer in food process equipment. We try to quantify heat transfer or plate heat exchanger, shear rate in tank, resonance time distribution in pipe, thermal profile in ohmic heaters. We also try to develop models in order to establish a link, a causal link between the outputs of the system and operating conditions. For example, how the dual revolution motion of the planetary mixer governs the mixing time or foaming abilities of the mixers. We have done the same job for weakly studied reactor, as for example, Mondo Mix, which is a continuous rotor stator mixer. We also try to understand destabilizing phenomena and how they govern deposit formation kinetic of whey proteins solution onto various surfaces of process equipment. For example, one of our questions is to find out the fallout precursor when whey protein are heat treated. In this field, we have shown that a correlation exists between unfolding protein species concentrations and deposit mass in the plate heat exchanger. On the right side, we have observed how proteins or mineral elements interact with the surface and participate to the fouling growth. We have started to do the same job with the more complex dairy derivative, for example, containing casein. Of course, we use experimental data. We use our own experimental data to develop predictive fouling deposit mass models for whey protein fouling solutions. Different modeling strategies are attempted: empirical, mechanistic, data-driven models to propose the best generic predictions. In this field, we also collaborate with the Imperial College of London. We also made some research to understand adhesions of spores, food bacteria, and biofilms formations. Some of them concern the role played by exosporium glycoproteins in the adhesions, the role played by the sporulation in the contamination of surface, the influence of biofilm growth in the resistance of biofilm to cleaning. We also laid investigation to understand cleaning and disinfection mechanism and hygienic design. It could be equipment mapping to detect cleanless place. It could be tests to evaluate the role of hydrodynamic in cleaning process, the influence of mechanical and chemical actions, or to check the performance of the detergent out. Last research in this field of our groups aim at reducing water consumption by using in situ prepared foam to clean the processing line. We developed sensor prototype to monitor food structure change under real-time conditions and also to monitor fouling rate and adhesion level of a deposit onto surface. You have here an example of sensor on the left to monitor structure change in the product or to monitor fouling formation into plate heat exchanger or pipe on the right. Of course, the sensors we develop are based on different physics principles. The last one are based on acoustic measurements. and they are able to measure stickiness of a product onto a surface, or allow to monitor soft solid removal or biofilm formation onto surface. Finally, to mitigate fouling or to facilitate cleaning, we developed some anti-fouling and hygienic surface using a different technique for coating. If you look on the bottom of the slide, you can see different plate of heat exchanger, and the plate represents the different channels, and you can see that the plate 8 is free of deposit. It is because this plate was coated by a new anti-fouling and hygienic surface. We make some publication, but we also provide some book dedicated to hygiene or method of modeling. And to finish this presentation, I would like to say that we organize at Lille in March the next fouling and cleaning in food processing conference. And you are all invited to follow and to register to this event. Thank you for your attentions. And next time, I will make more technical presentations speaking about influence of calcium on fouling for various whey protein solutions. So thank you very much, and I give the microphone now at Antonio.